Hello, so in this video we're going to go through some commonly wrong answered GCSE maths questions. In particular this week, so we've got three different topics. We've got simultaneous equations, we've got right angle trigonometry, so SOHCAHTOA, and we've also got pyramids, so find the height and the volume of a pyramid. So what I suggest that you do is that you give these three questions a go and then you watch the video to see what the common traps might be and how to do the questions. But part of the reason for that is if you get to actually go through the question yourself first, get that experience of either getting it perfectly right or getting it wrong and seeing where you went wrong, that means it's very unlikely that you'll make that mistake again, especially if you manage to push yourself so that you understand why that's the case. So, as I say, three commonly wrong answered questions, quite challenging questions. So, let's look at this first one. So we've got simultaneous equations. We've got 2x plus 5y is minus 7, 4x take away 5y is 16. It's quite a standard question. We've got that the y's match up. We've got a matching coefficient. We've got the same number in front of the y's. However, we've got a different sign. People can sometimes jump because they just look at the x's and decide that way. So, because the y's are matching, we've got to look at the sign in front of the y's. Okay, now we need to get how we can make 0. So I've got plus 5y and minus 5y. If I add them together, I'll get 0. If I did 5y minus 5y, that would give me 10y. So I'm going to be adding the equations together to get 0. Okay. If another way of trying to remember it is SSS, same signs subtract, as I was taught it. We have different signs here, so therefore we must add in the opposite. Okay, for subtraction and addition being opposites. We've got a trigonometry question. It's given away by the fact that it mentions we've got cos. We've also got a right angle triangle with an angle. So again, that's telling us that's probably cos involved. And they give a common piece of advice is that you might not see right angle trigonometry on a non-calculator paper. What they've started to do the past few years is give you some exact value or expect you to remember it and ask you to then still do the question on a non-calculator paper just using this piece of information that they're giving you. And it can be quite difficult to work out how to use this piece of information effectively. And sometimes it's made it more complicated than what you're used to, as if it were on a calculator paper. Okay, because it's slightly different to what you might have practiced before. And then 3, we've got a pyramid. It says find the height of the pyramid and find the volume of the pyramid. So the height, we're referring to the highest point here. So thinking about that distance there, that would be what our height is. And it says find the volume. Now the volume, I believe you should be given it. It's not on your formula sheet, so it's a third times the base area, so the area of the square at the bottom, times the height, which is what they've asked you to work out in part A. This could easily, however, be a longer question. It could be a 5-6 mark question where you've got to solve the problem for yourself. You've got to realise, oh, I need the height first, and then I can put that into the formula. So make sure you understand the individual steps now to work out what each bit, but how it fits together as a whole. We're trying to find the volume of the whole pyramid. To do so, we need the height to be able to put into that formula. So you might want to, if you haven't already, you might want to now pause the video and give these questions a go now that you've seen a few of these points mentioned beforehand. Right, so let's have an actual go through these questions now. So as I say, we've got a matching coefficient in front of the y, we've got 5 in front of them, and we've got a different sign. So the first thing I do when I'm looking at simultaneous equations is look for a matching coefficient. And it's not really a coefficient, I guess, but all we're looking for is a matching number in front of x or y. If it's not there, you would have to make one by multiplying out the equations to get it to be the same. And then we're going to think about either adding or subtracting the equation. Okay, so add or subtract is going to be the next sort of key step. Now, as I say, we've got SSS would be same sign subtract. We've got a different sign in front of the y's, so I'm therefore going to add these two together. The 2x plus 4x, that's going to give me 6x, 5y plus minus 5y is going to be 0. then we've got minus 7 plus 16, that's going to give us 9. So to work out what 1x is, I'll have to get from 6x to 1x. I think what's the opposite of times in by 6? It would be divide by 6. So I need to do the same to this side, divided by 6. I've got 9 divided by 6. Now you could simplify that as a fraction, divide both of them by 3. Get 3 out of 2. So you could say x is 3 out of 2, or you could say it's 1.5. Both would be correct. You can leave it as 3 out of 2. So what would that step there? So when we've done so, we've then solved the equation after adding or subtracting them. We're not done yet though. We've found what x is, we've not found what y is. So our fourth step is then going to be substituting x into one of the original equations. Okay, so I'm going to put the first one to the top one, was that 2x plus 5y is minus 7. So if x is 1.5, that means 2x is 2 times that, is going to be 3. So in other words, this whole thing now is just going to be 3. So 3 plus 5y is minus 7. And we'll sort them around just to make it a bit easier. So 5y plus 3 is minus 7. That's because no matter which order I add things. So then what's the opposite of adding 3 to something? It would be to take it away. I'm very careful here. Minus 7 take away 3 is minus 10. And then to get y on its own, opposite of times in by 5, divide by 5. 10 divided by 5 is 2. So minus 10 divided by 5 is going to be minus 2. So they're both our values. So we've got x is 1.5. We've got y is minus 2. Okay, that means if you were to plot those graphs together, it would intersect at the coordinate 1.5 minus 2. That would be the point of intersection. But let's think back to what we did. So sorting out whether we're adding or subtracting, solving the equation, substituting the original equation, and then solve that one. And then state your values at the end, just to make it really clear what your answers are. Okay. Right, so this next one, we've got some right angle trigonometry. If I straight away see a right angle, I think I'm thinking of either Pythagoras, trigonometry, or area of a triangle. Now, we've got an angle, so pretty much that tells us it's going to be trigonometry, and the fact that we've got something to do with cos, again, is telling us it's trigonometry. So our first step would be to write down SOHCAHTOA, and then label in our sides. So figuring out what we've got here, so always opposite the right angle is the hypotenuse, opposite the angle is the opposite, and then the one next to the angle, the one that's left, is going to be your adjacent. So then if we're thinking about which one it's going to be, we've got A and we've got H, so we're going to pick out CAH. So if that wasn't obvious from the question, you now know that we've got CAH from looking at it that way. So cool. We then want to, depends which way you want to solve it, whether you're happy with forming triangles or with writing out the equation. But either way, we're going to need this piece of information here. So we want to calculate the hypotenuse. So if I was doing it as a formula triangle, that would be covering up the hypotenuse, and we're doing A divided by H. So A divided by cos, and cos, what goes into cos is the angle. Okay, and then we have to go what our values are. So A is 5. I'm going to write it as a divide here, because I'm going to have to divide by something. It's going to be a fraction, because cos 45, we want to find out what the value of that is, and that's what's given to us up here. So I need to divide it by root 2 over 2. Now you might not keep flip change, so keep the first value, flip the second one, change the divide into a multiply. Because 5 is a number on its own, remember that 5 is the same as 5 divided by 1. Then we're multiplying two fractions, times the top 2, times the bottom 2. You might be asked to give the answer in the form a root b. So we might have to do something about this root 2 at the bottom, because usually we don't like having surds at the bottom. So the way to do that would be to rationalise the denominator. So we times by root 2 over root 2. So 10 times root 2 is 10 root 2. Root 2 times root 2, well, that's root 4, which is the same as 2. Just being careful when you multiply the numbers. If they've both got a square root, you can times what's inside them. If they've not, you can't, so that's why I've not at the top. And then 10 divided by 2 is 5, so that would be 5 root 2. And that would be the exact length. Now, forming triangles are good for a shortcut. If we're doing it slightly differently, I would say, I'm not using forming triangles, I would say cos 45, looking at cas at a divided by h, and a over h. And then how do I can times by h, so cos 45 times h is a. Now it doesn't matter which order I times things, so I'm going to write it like this. So then to get h on its own, I would have to divide by the cos 45, which is what I've done here. So the forming triangle is just a shortcut for doing that, but please make sure you're comfortable with solving equations. So what are the common pitfalls there? The most common one is actually just using this boxed information that you've been given, the fact that cos 45 is root 2 over 2. So realising how you're going to use that. So if you're dividing, it's easier to write it like this, because then you can keep foot change and think about how you multiply or divide fractions, whatever method you use. Okay, and then remembering this little bit here about rationalising denominators to get it in a particular form, but it will tell you in the question. So our value for x would be 5 root 2. Right, so this third question, we have got a square-based pyramid. It tells us to find the height and then find the volume. So as I wrote down earlier, the volume is a third times the base area times the height. And we're asked to find the height. Now let's annotate. We've not got any values on this, so let's look. A to B is 7. I know that this bottom part is a square. It tells me it's a square-based pyramid, so all those lengths are 7. And we want to find the height. We're told that AE is 16. And that's the diagonal distance. And we're thinking in 3D here, so you should be thinking about 3D Pythagoras. Now, the way I think about it is that we've got d squared, this is our diagonal distance, is the length squared plus the width squared plus the height squared. Okay, now we need to think about what our length, width and height are. Now, we're going from A to this point at the top, E. So let's figure out what path we're going. So I'll be going 3.5 that way, 3.5 that way, and then H all the way to the top. So I've had to half those values because I'm going to the middle. So I'd have 3.5 squared plus 3.5 squared plus H squared. And I actually know what D is. D is 16, so that's going to be 16 squared. So I can put all those values in. So if I do 16 squared, that gives me 256. And then 3.5 squared plus 3.5 squared, I'm going to do both of them together. That gives me 24.5, so that's doing both of them, plus h squared. Okay, so now I can find h squared by taking them away. 256, take away 24.5. That's going to give me 231.5. That's h squared. I want h, so I need to square root that value. Okay, so square it out on a calculator. I would get 15.215 to 3 decimal places. It'll tell you normally the exam I have here your level of degree of accuracy. Okay, so that's really a 3D Pythagoras question where we're finding what the missing height is to get that distance to be 16. So the key bit where people fall over here is thinking about that we need to halve this distance. and actually recognising that it's 3D Pythagoras in the first place, because we've got distance between 2 points being 16. I'm thinking about how can that be so with that distance. Okay, and then for part B, we've got to find the volume. So all we've actually got to do now is just use that formula that we've just done. Okay, so the volume of the pyramid is a third times the base area. Now the base is a square, the length is 7, so that's going to be 7 times 7. So 7 squared would be the area. Well, that's going to be 49 times the height. So volume, put that as a calculator and get a value. So this one probably would be on a calculator paper. And I would get 248.512 to 3 decimal places. And something key I've got in here, H, well, it's 15.215 centimeters. Got volume, so we're thinking about centimeters cubed. Okay, so that could be asked as one question on its own rather than broken down into part A and part B. So we got why did we need the height to get the volume, because the height's in the formula. And we need to calculate the area of the square, which it asks us to, but we need to realise to do that because it's just 7 times 7 for the area. Then we need that in the formula, so thinking about where these values are coming from. So think about your end goal. If it just said find the volume, think about pieces of information you need. Area of the square, height of the pyramid, how can we find those? Area of the square is just a square of whatever the side length is. Height of the pyramid, we have to use 3D Pythagoras for that. Okay, so it might be worth now actually, now that you've seen those, give it a bit of a break. Come back and see if you can do those questions for yourself later on if you couldn't in the first instance. Okay, thank you for your time. Best of luck.